Hello everyone. VLANs appear on CCNA exam and in every enterprise environment. Today we learned that how can we create VLANs, how can we assign ports to the VLAN, and how can we configure the trunk link from zero. And in tomorrow's video, I'll explain Inter-VLAN routing. If you want to have a free session at packetmentor.com, I'll drop a link in the description. First of all, we need to learn what VLAN does. By default, every device in the same VLAN, VLAN 1, which means all devices are in the same broadcast domain. If all devices are in the same broadcast domain, what will happen? If one device start communication, the message will be forwarded to every other device. So let's see in the simulation mode. If you ask ping 192.168.1.7 from PC number 4. In the simulation mode, you can see that the message is forwarded to every available port and then to the every available port on the switch number 2. This creates two problems. One is a security hazard because unintended communication starts happening. And second, the bandwidth problem. So let's analyze this topology. For example, in this office, we have two different floors. This is the ground floor and this is the first floor. In the ground floor, we have the sales team, and in the upper floor, we have the IT team. On the ground floor, we want to have a person from the IT team as well. In case of emergency, he can take care of the things. But on the upper floor, we do not require any salesperson. So what we can do, we can divide our network into multiple VLANs. VLANs is basically virtual segmentation on a switch. Each VLAN will behave as they are connected with a totally separate switch. In this case, what will happen? Broadcast communication will remain within the VLAN. It will not send out of the VLAN. So let's see how can we do that. So first of all, we have to decide that we have to give a VLAN number to each department. For example, to sales, I'm going to give the VLAN number 10. To IT, I'm going to give the VLAN number 20. Okay, I'm going to the switch config T interface range fast Ethernet 0/123. So I'm going to configure interface number 1, 2, and 3 into VLAN number 10, which belongs to the sales department. So I have selected the range. Switchport mode access. I have to convert these ports into the access port. By default, they are in the auto mode. Then switchport access VLAN 10. So this is the command which is used to transfer VLANs from default VLAN to VLAN number 10. Since VLAN 10 is just created, we can go to the VLAN 10 and we can give it a name as well, which is the sales. And write show VLAN brief is the command to verify it. So now you can see that we have configured VLAN number 10 with the name sales. VLAN number 1, 1001, 1003, 1004, and 1005 are available in the initial configuration. Any other VLAN, for example, VLAN 2 was created before in this switch, and VLAN 10 we have just created. Over here, this is the normal range of VLAN which can be assigned to the departments. Now we want that our PC number 4 should belong to the IT, and in this case, config T interface fast Ethernet 0/0/4 switchport mod access switchport access VLAN 20. Go to the VLAN 20 name IT and write show VLAN brief. Now you can see that we have created another VLAN named IT and we have assigned port number 4 into that VLAN. So when this VLAN will be up, now you can see that if we will try ping 192.168.1.4, let's start the simulation mode and enter. When switch receives a packet, it will send the packet into the same VLAN only. It will not forward the packet to any other ports. Now you can see that the packet has not been forwarded to the ports which are not belong to VLAN number 10. So this is how we have created the VLAN, and this is the benefit of the VLAN. And now you can see that our PC number 4 connect to the same switch, but since it is in the different VLAN, now it cannot communicate with the devices in the VLAN 1. So let's do the same configuration over the switch number 2. In this switch, we have all the devices in the same VLAN, VLAN number 20. So we will enable config T interface range fast Ethernet 0/1 to 4. I'll select all the 4 ports and switch port mod access, switch port access, VLAN 20. So VLAN 20 was not there. So name right and right. So let's verify show VLAN brief. Now you can see that VLAN 20 has been created and port number 1, 2, 3, and 4 are transferred to VLAN number 20. In this case, if PC1 want to communicate with PC number 8, so ping 192.168.1.8, and let me start the simulation mode and just enter. Now you will see that the packet will be forwarded to the ports within the same VLAN only. The packet has not been forwarded to the port which is not belong to VLAN number 20. But here comes one problem. In this scenario, our devices are on the same switch. We are able to communicate with each other. That's what we are looking for. But in our case, one of our device is on another switch. And we know that by default, our communication cannot go outside the VLAN. But in this case, we need this device to to act as a part of this network. So how can we achieve that? How can we make this link able to communicate multiple VLANs? Because by default it is in VLAN 1. It will not be able to communicate our VLAN 10 or 20. So let's see how can we do that. For this purpose, we have to create these interfaces into the trunk mode. We have to create this link as a trunk link. Trunk link use 802.1 flags and allow all of the VLAN traffic. So how can we configure? Let's see. Let's go to the switch 0 first. Config T interface G0/1 switch port mod trunk. This is the command. And if we go to the other switch, second switch, config T interface G0/1 switch port mod trunk and right and to configure to verify show interface trunk. Now you can see that port number G01 using 802.12 encapsulation and status is trunking and with native VLAN 1. And this trunk port allow VLAN number 1 and 20. Now let's see what will happen if now device want to communicate with the PCs 192.168.1.255. See into the simulation mode, forwarded the traffic to the switch, and taking now switch has taken the traffic to the other switch. And on the other switch, since traffic was belong to VLAN 20, so other switch has forwarded the traffic only within the VLAN 20. It has not forwarded the traffic to the VLAN number 10. So it maintains the protocol. Let's analyze now how devices in VLAN 10 will behave. Let's ping ping 192.168.1.255. I'm pinging the broadcast address and on the simulation mode. For traffic is forwarded to the switch. Switch is forwarding traffic to the ports in the same VLAN as well as in the trunking into the trunk port. And when the packet is arrived on the other switch sees that I have no port in the VLAN 10, so it will discard the packet. This is how access port and trunk port works. And now if you try to communicate across the VLAN, ping 192.168.1.4, it will not succeed. And this is the by default behavior. In tomorrow's video, I will explain that how can we enable inter-VLAN communication. If you have any question regarding this, let me know. Tomorrow's topic will be router on a stick. And if you have any question, drop it below. I'll explain in the next video. Thank you so much.